recording. Okay. And where did it go? 4.1 J. There we are. The leveling effect. There's only one page. And I was too lazy to like type it. So I just took some notes that I wrote in a previous semester and stuck it in here. So the leveling effect essentially says two things. Yes, it's not plugged in. That's not helpful. Thank you very much. There we go. There we go. Okay. That should be better. Why is it so high up? Bring that down a little bit. There we go. So the leveling effect says that hydronium is the strongest. Oh, I'm missing a word here. The word is acid. Fix. That can exist in water. And that little last part, you'll see it's double underlined. That is the key. Okay? Because all weak acids exist in water. So if you had weak acids exist in water. Okay, so if we had, for example, CH3COOH in equilibrium with H plus, plus H2O. In equilibrium with H3O plus CH3COO minus. The CH3COOH at equilibrium, do we have some or do we have none? At equilibrium, we have some or none. Some. So what that means is that that acid exists in water, okay? However, on the other hand, if we have a strong acid, okay, so this is a weak acid, weak. If we have a strong acid like HClO4, it will also react with water, but it goes all the way to completion, and it is all gone. Yes. So if the HClO4 is all gone, does the strong acid exist in water? It's all gone. Does it exist in water? Is there any of it left? No. Okay, so it has all turned into, it has given all of its protons away and has turned into the ion and the hydronium ion. So anytime you have an acid that is stronger than H3O+, it turns into H3O+. Yes? Any acid stronger than H3O+ will ionize 100% to produce H3O+. 0% of that acid exists in water. So if we look at our chart, our data booklet, here we go. That's not the right data booklet. Sorry. Acid-base table, there we go. So if we go up, you can see where is hydronium on our acid list. It is at the top of the weak acids. Weak acids exist in water. It is the strongest of the weak acids, so it is the strongest acid that exists in water. All of the rest of them, all of the strong acids, do not exist in water. Is good? And that's all there is to the leveling effect. Okay? You don't need to know anything else about it. So if someone asks what's the strongest acid that can exist in water, you'll say H3O+. Okay? And it works the same way for bases. Can you guess what the strongest base that can exist in water is? OH-, yes. Okay, so again, in our data booklet, if we go down our bases, if we go down that right-hand side, the strongest base that can exist in water is OH-. And then the strong bases will grab hydrogens and will cease to exist. Okay, so let's go back here. So let's just skip that middle part. We'll come back to it in a moment. What is the strongest base that can exist in water? That is OH-. Any base stronger than OH- will ionize 100% to form OH, leaving none of the strong base existing in water. So this is all gone. Now there's a little bit more to the leveling effect than this, but I don't even know if you really need to know it, but let's go there anyway. And that's this middle bit here. What if the solvent was NH3 and not water? So what if you had ammonia, just pure ammonia, and you started dissolving acids into it? What would be the strongest acid that could exist? When water is the solvent, the strongest acid is H3O plus. When NH3 is the solvent, the strongest acid is NH4 plus. This, like I said, do you really need to know it? Probably not. But what that would mean is that every single acid that is above NH3, sorry, NH4 plus. So if we had the solvent NH3, all of these ones here, let me highlight them for you. All of these ones here everything, all the way up there, all the way up there, those would all be strong acids. They would all dissociate completely if ammonia was the solvent. Yeah? And what would be the strongest base in ammonia? The strongest base that can exist in NH3. Now remember, the strongest base in water is OH minus. Who is the strongest base in NH3? NH2 minus, yes. Okay, but like I said, the stuff in the blue box you probably don't need to know, so if that made absolutely no sense to you, you can just be like, fine. The strongest acid that can exist in water is H3O+, the strongest base is OH minus, and you can just leave it at that. And that takes care of the rest of 4.1. Any questions? Nope. All right, now we're going to finish up 4.2. There's a lot more to 4.2 than there was before, so we're going to go to 4.2D, which is on page 85. Okay. So now we have, we should know, you guys should know that a solution is neutral when hydrogen concentration and hydroxide concentration are equal. A solution is acidic when the hydrogen is greater than the hydroxide. A solution is basic when the hydroxide is greater than the hydrogen. Does that make sense? That should make sense, I hope. Fingers crossed, yeah? Why does pure water have a pH of 7? Could you do some math on around water to figure out why it has a pH of 7? What does pH 7 mean? pH 7 is neutral. What else is true if pH equals 7? What other number can we say is true? If you know the pH, you also know the pOH. So the pOH is, okay. What else do you know? Pardon me? We know the temperature. The temperature is 25 degrees Celsius. What else do we know? Sorry? We know pKw. Yep. pKw is 14.00, but I'm just going to be lazy right now. Yes. We know the concentration of H is, everyone know the concentration of H? 1 times 10 to the negative 7. Yeah? You could just write 10 to the negative 7, but we're going to get into other things times 10 to the negative 7. And what is the concentration of hydroxide if the pH is 7? 1 times 10 to the negative 7. So we know that all of those things are true if we have pure water at 25 degrees Celsius. All of those things are true. And we also know that Kw is equal to 1 times 10 to the negative 14. 1.0, but I'm being lazy, okay? So the reason we know that water has a pH of 7 is that we are given the information that at 25 degrees Celsius, they say room temperature here, but room temperature is 25 degrees Celsius. Water has a Ka value of 1 times 10 to the negative 14, okay? So, Kw is equal to the hydrogen times the hydroxide, which is 1.00 times 10 to the negative 14. I'm putting that extra 0 on there because we're going to want to play with decimals a little bit, okay? We just need more sig figs. And if it is pure water, then hydrogen and hydroxide must be concentration of hydrogen and hydroxide in pure water (10 to the negative 7). In other words, and hydroxide is 10 to the negative 7. So in other words, the two of them are, how do they compare to one another? They are equal. Oh, look, right here it says they must be equal. Okay, so the hydrogen ion concentration, the hydronium, must be equal to the hydroxide if the water is pure. Okay, so if we write what do we call this reaction here? We've got two versions of this reaction. What do we call that reaction? Tell your partner. What is the name of that reaction or of that reaction? That is called the auto ionization of water. And because it is a 1 to 1 to 1, that means that hydrogen and hydroxide are equal. Unless we throw something else in there. If we threw in some HCl, the H would go up and the OH would go down, okay? But right now we're dealing with pure water. So if these two things are equal, you could say that the concentration of hydroxide is the same as the concentration of hydrogen. So you can actually replace hydroxide with hydrogen. Is that true? Can I do that? Can I say that H times OH is now equal to H plus squared? Yes. If you wanted to, if you did not want to write it this way, you could say, let X equal the concentration of hydrogen, which is the same as the concentration of hydroxide. And you could say that Kw then is equal to X squared. Yes? Is that correct? Or you can say Kw is equal to H plus squared. Yeah? And if H plus squared is equal to 1 times 10 to the negative 14, we get H. We take the square root. And H is equal to 1 times 10 to the negative 7. And hydroxide is the same as hydrogen, so it is also 1 times 10 to the negative 7. So even though you know those numbers, this is how you could prove that. Yes, at 25 degrees Celsius, you can prove that hydrogen is equal to 1 times 10 to the negative 7 from the value of Kw. Okay. Okay, and this just goes over, yes, now we know that the pH is 7 and the pOH is 7, and there we are. Okay, so all of that is just going over stuff we already know. But now what we're going to do is we're going to mess with the temperature. So we have a table here that shows the temperature dependence of Kw. So at 25 degrees Celsius, okay, your first column is the degrees Celsius. And you can see that at 25 degrees Celsius, we see that familiar value, 1.0 times 10 to the negative 14. Yes? I would like you to find the concentration of hydronium, in other words, i.e., the concentration of hydrogen in pure water at 0 degrees Celsius. How would you do that? This is your Kw. And you can use 25 degrees Celsius as a model. How did we get 1 times 10 to the negative 7 molar for concentration of hydrogen from, how did we get from the Kw to the hydrogen ion concentration? See if you can figure that out. What do you mean, what about 0 degrees? Would it be different? Is the equation any different? Why would it be different? Yes. That way you can do one test. Yes, I love it. Yes. I don't know. Oh. Uh-huh. I watered it up. You just did this. You just are one sensitive today. This is pKw, right? Your pKw, which is equal to high frequency. That is yes. high? 86. 86. That looks beautiful. Yes. Very nice. Yeah. Oh my God. Wait. Whoa, that's Ugh. There we go. Yeah. Okay. So by this point, you should be getting close to having this all filled in. Yes? You can check your numbers there, see if you did it correctly. Now, what I'd like you to notice is that if you take your pH and you add to it your pOH, So if you take pH and you add pOH, what do you get if you add pH and pOH? pH plus pOH is equal to pKw. Okay. And if we have pH plus pOH equals pKw, you'll notice that at 25 degrees Celsius, we have 7 plus 7 gives 14. Yes? What about at 0 degrees Celsius? What is pKw? What do you get? Do you get 14? No. You get 14.9. Why is my calculator not waking up? Wake up, calculator. 7.472. 14.944. Yes? So go down and calculate all of the pKws. So it turns out that at temperatures other than 25 degrees Celsius, pH plus pOH do not equal 14. They equal something else because Kw equals something else. And that's because what is the only thing that can change a KEQ? Temperature. And we have changed the temperature, so we're getting different values. All right, and so if we go back here then, you should, in theory, from this data here, be able to tell if the autoionization of water is endo or exothermic. See if you can figure that out. Is the autoionization of water chat with your neighbor about that. Exo, why? It's just a guess. Okay. How about you look at some of the numbers that we have? I don't know whether you're right or wrong. You can't justify it. Yes. We can fix that. So if this were exothermic, yes, then the heat term would be over here, yes? If it were endothermic, the heat term would be over here. So let's just pick one of these and say what would happen. What would happen if we increased the temperature and our heat was on the left? If heat is on the left and we increase temperature, what would happen? What would happen? The equilibrium would shift which direction? If we increase temperature, it would shift to the left, to the right. Which one? To the right. Why would it do that? It would do that to absorb the extra heat to bring the temperature back down. If the heat was on the left and we increase the temperature, the system would shift right to use up heat and bring the temperature back down. Is that what happens? And how do you know? So if we increase temperature, what should we look at for what happens when we increase temperature? Which values should we be looking at in the table? Here's 25 degrees Celsius. Where should we be looking? We should be looking at kW. kW is a good one, yes? And should we be looking above 25 or below 25? Above 25, thank you. Why would we look below 25? We increase the temperature. If we increase the temperature, is the temperature bigger or less than 25? Bigger. I feel like I've said something that has confused people. So, on the table, yeah. But yeah, I see what you're doing it directionally and I'm doing it temperature-wise, but you mean the same thing as me. Okay. Yes. So we would be then looking at these values here. I get it. I knew there was some sort of confusion. I'm like, surely you can. Okay, yeah. We're good. All right. So we're looking at these values here. What can you say about those values? What can you say about, in reality, when temperature was increased, the system shifted which way? Are those numbers bigger or smaller than 10 to the negative 14? Those numbers are bigger than 1 times 10 to the negative 14. So did the system shift to the right or to the left? It shifted to the right because we have more products, okay? The system shifted right. We know this because kW got bigger. More product. Yes. Sorry? Okay, so this value got bigger, yes? And this value is kW, which is hydrogen times hydroxide, yes? And our equation, if that number got bigger, that means our, come on, there we go. This got bigger, which means this got bigger, which means it shifted to the right. Does that make sense? Cool. Okay. Thank you for asking. I appreciate that. So, in reality, when temperature was increased, kW got bigger, so we know it shifted right. Is that what we predicted if the heat was on the left? Yes. These match up. Therefore, the heat was on the left. Therefore, the reaction was endothermic. So that is a question that could easily come up on a quiz or a test. Okay? Good question. And actually, I could have asked that to you in the last unit. I could have just given you the information in the last unit and asked you about that. Okay, Next, write a formula to calculate how to calculate the concentration of H3O plus in pure water. Tell your partner, how do you calculate the concentration of hydrogen, because that's the same as H3O plus, in pure water? So you're going to go back and you're going to be like, how did I find this hydrogen ion concentration? How did I get that? What did I do? What did you do? Because the hydrogen oxide. Yeah. Okay, what did we get for finding hydrogen in pure water? Square root of what? Okay. W. Okay. What is true about hydronium and hydroxide ion concentrations in pure water? They are equal. Is pure water acidic, basic, or neutral at 50 degrees Celsius, and how do you know? So we know that actually, I'll let you talk about it first. There's more to write down than that for sure, but have a chit chat about it. Okay. What do we think? Acidic, basic, or neutral? Let's go back to the very first thing that we looked at today, at the very, very beginning. A solution is neutral when hydrogen and hydroxide are equal. Yes? You have to have more hydrogen than hydroxide for it to be acidic. Acidic, not hasidic. It's too funny. Okay, so we go here and we say, all right, well, these two guys are equal. You do not have more hydrogen, you do not have more hydroxide. Therefore, the solution is neutral. So you have more hydrogen and you have more hydroxide. So even though the pH is 6.145, at 50 degrees, neutral pH is 6.145. So the middle isn't 7 anymore. The middle is 6.145. Yeah? Okay. Do we have anything else to learn here? No. We're done. Okay, now, you have a quiz on Monday on Ka, and I'd also like to throw in a little bit of this effect of temperature. So what you need to do is you're going to need to do 4.2D. So that would be page 87 and 88. That's the temperature, pH, pOH. And then for extra Ka practice, page 152 in Hebden. Numbers 74 to 83. Well, let's not do 83. Let's do 82. If you want to challenge yourself, you can do 83. Okay? So this would be Ka. And your quiz on Monday will cover both of those. So quiz Monday, test is next Friday. Hi. Yes. Yeah, yeah.
Just unplug it, don't do anything to me.
Either way, you can turn it off and unplug it, sure. we go.
I noticed something about the light staying on. It's okay, right? It's hot.
Especially because it's lunchtime.
Right. So
Right? So
technically, anytime you see a hot plate, it should be like, oh, there's a hot plate. I don't know, I can't touch it. So maybe the big is plugged in, so they see the red light. But then it'll be so. See, I think it's like, well, I don't think like
you too.
That's one of the reasons why. The world is what it is. So when we teach, then you also realize that it's also full of some very deep. I was more that's like maybe I have to go in. I know. If I were, if it were here, I would see it. And it was just speaking of, there's a reason why people are not. But they're all there. Yes. Yeah. Like I was in, and I'm like, I would not sit. I feel bad if we got these things to this massive. Here we are, running on it, go back. And I have to get out of them, but as I was saying, I wouldn't. But anyway, you have to stay. I probably a little bit more. Yeah. Yeah. My dad was reading here today. Okay. It's philosopher. It's Kierkegaard in my it's someone else.
I'm trying to think, is it Kierkegaard? It's one of the philosophers, Kierkegaard.
It is Kierkegaard.
But there's another one who I'm thinking there might be another one.
Is he nihilism? Is he? Like I think
Or am I thinking of a different person? Okay. I guess it's not
Nihilism. Nihilism? I would count.
that's not one. Yeah, there's that for sure. Nietzsche. That's what I'm thinking of. Friedrich Nietzsche. My dad's saying Nietzsche right now. Yeah.
Nietzsche is freaking people.
But he's enjoying it.
I'm glad he too. He just gets a lot of
Bye.
Should study more.
I should study more philosophy.
Yes. Oh, when I retire, oh yes. But it's funny that no. Okay, so the Camino is computer to Santiago. I think it's a pilgrimage walk, right? Catholic, but I'm not Catholic. It's walked by all kinds of people. It's in Spain. No, it's like very both of them. Yeah. You know, Paul Coelho's The Pilgrimage? Oh, yes. So, was it this book? I think so, yes. Yes, probably. I know that.
So I haven't read it. I feel I need to read it between now. I'm going next summer, not this one, but next one because I'm trained for it. But you're walking up to, well, some people walk up to 30 and more kilometers a day. On my longest distance is maybe 24. I'm doing a slow with people. So there's a couple of my days that are more like 10, but usually it's sort of between 15 and 20.
Also depends on the
Yes, exactly. So I picked my days when there's more, are much shorter. Yes. Well, I don't have to, because I'm like, it's my goal to go walk that much.
No, if he manages to get a job, it would be good. And if he doesn't manage to get a job, then it would be, right, you know. But I'm check those stuff right there. But what, you know, I don't. Oh, yeah. No, it's really fairly safe. And I'm, you know, that's another thing. I would like to do with joint. That's why I'm saying. And although I have booked my places, if the training does not go well, and I'm like, this, I think will like destroy my body, I'm just, right? That's why I'm giving myself a year to like make sure it's okay, because I don't want to wreck myself. That's why you're taking it super fast. I'm taking Zumba, I think that I really gotta start focusing on like walking longer distances. Right now, I can walk 10K. And I still think stuff walking stuff. This is not something that's still crazy. There's a picture that comes from the Philippines. The sun is going to start. Yes, it is the north of Spain, so it's not as bad as St. Madrid, but it's still going to be hot. But I have a sun hoodie, which is like very, very light, white material, sun hoodie. So for tracks. Yes, yes. And I have decided to it, or just bring the vitamin pad, and so I have the sun glow with like silver. But I also do. Okay. I also keep the weight down. So yeah, this summer is like my plan. Prepping, so I've done some of the planning prepping. You could also consider that for your diet is with the oh, I don't like. No. And then if you have made on confidence, right now, it just gets so bad.
No, look, this is my fleece. Yes.
What is this wood on?
This is synthetic.
Oh.
Okay. It is made of probably polyester, I'm guessing. No, merino wool or polyester. This one is most fleeces. Polyester, yes. Yeah.
You're well prepared.
Oh, I'm willing to spend money on it because like this I bought, and I'm like, look how well it goes with the colors today.
It does.
Right? I'm like, oh, and it went with my colors yesterday too. So it's not like I just bought it just for the trip. It's something I can wear other times too.
Nice.
So yeah, so everything that I'm spending money on for the trip is almost everything is things I can use other times.
So also consider skiing and stuff.
Cross country skiing.
You do? You like cross country?
I like it. It's not that I don't like skiing. I find it's a lot of money and time for the amount of enjoyment I get, and I get very cold going up the hill, and I get hot going down the hill, and I'm like, up and down and up and down, and like I'm not good enough skier to make it super fun. You know what I mean? So I'm like, and it's so expensive. So yeah, cross country skiing I love. Yeah.
That's one reason I'm looking forward to getting it recently, because we get discount passes.
Oh, very nice. Yes.
I don't know. Should tell me how it goes though. Like
I will. You have to keep in contact somehow. I'm on Facebook, if nothing else.
I'll make a Facebook account.
Okay.
Because I'm planning on going on trips as well.
Yep.
Especially, hopefully after I finish my reviews.
Yes. Yeah.
Then I was thinking something along the lines of mountains first, because they're hard to.
Yes. When you're young, go do the hard things.
Yeah. Even my dad wants to do it, but he's like kind of old now. So.
Yeah.
Which is why my mom starts crying. She's like, "You'll die out there." Like,
my mom is not so thrilled about this. She knows better than to say it, but I can tell she's like, "Oh, by yourself?" I'm like, "Yep." Yeah. Oh. And then she's like, "No, you could go walk across England," because somehow she thinks like England's more safe than Spain.
And I'm like, okay, whatever. Anyway, like she's got whatever her ideas are. She's 82. She's had a stroke. Whatever.
You should go to Scotland for them.
I could. There's a West Highland Way. I could do that. Well, but yeah.
I want to go to Scotland. Yeah.
Yeah. My parents did not like Scotland. They were underwhelmed by Scotland.
Really?
Yeah, because they were like, it was very gray. It was very cold. And they're like, I could have done that here.
I mean, Scotland, Ireland, and most of the other countries are basically like
Yeah. They really enjoyed England, but they just did not, they were not so keen on Scotland.
I went to Germany at a good time, so it was kind of different. Otherwise, trying to do it is the same.
Yeah.
It's pretty cool.
Yeah. My parents said they got a lot of the Scottish culture going to the Maritimes, like the sort of, some of the culture there, and it was a lot nicer. In the summertime. You want to go where?
Guinness.
Ah, Guinness.
I had some Irish too, so.
So I do not like any kind of beer, let alone Guinness.
I don't know, I have tried it all.
You have to try it. Oh, that's right. You got to try things. Yeah.
Thank you.
Okay. See you later. Hi, Ben.
Hello.
How are you? Good. Have I pressed stop on recording? No, I have this whole like thing on record. That's great. Stop recording. There we go.